Hi everyone. So Maxwell's equations, or Maxwell's correction to Ampere's law, shows us how there is no such thing as an electric and a magnetic field, but there's one common unity here. And essentially, Maxwell's correction shows us how a changing electric field induces a magnetic field, a curled magnetic field. Well, Faraday's law actually is parallel to that because we have a magnetic field, a changing magnetic field, inducing a curled electric field. So these two combine together and in fact can create an actual kind of resonance where if I have just the right kind of changing electric field, it will induce a curled magnetic field. And if the changing electric field changes in the right way, that magnetic field will change in just the right way that it will induce a secondary electric field that changes, and so on and so forth. And so not only do we get this kind of resonance that occurs, but we actually have the electromagnetic field feeding itself without any mention of charge or current at all. And this is called electromagnetic radiation. The field itself is able to hold energy and momentum and transfer it through space. And that radiation is what we talk about when we talk about electromagnetic radiation. So it always requires an initial motion of charge to spark this electromagnetic field. But Maxwell's equations allows the field to feed itself and allow that energy to propagate through space. And so that radiation is what we call light. And so that's one of the powerful things of Maxwell's equations, is that when he went through the mathematics and realized there was a wave radiation associated with the electromagnetic field, basically he calculated what is the speed associated with that wave. And here's the formula. The speed is associated with the magnetic constant in, we saw this in Ampere's law, but also when we talked about parallel currents attracting one another, this was the fundamental constant in there. This is the fundamental electric constant. So electromagnetism combined together right here, it's the square root of the reciprocal of the product. Calculate that number, lo and behold, it is exactly the speed of light. In other words, Maxwell's equations give us a mechanical model for light. This is the answer to the question, what is the ether? The thing that is waving. What is doing the waving in electromagnetic radiation, or in the motion of light? It's the electromagnetic field. So that's pretty cool, and that's one of the reasons why Maxwell's equations are so celebrated. Like I mentioned, that whenever to get the initiation of electromagnetic radiation or light, in order to get that started, we need the motion of charge. And so this picture here represents what the pattern looks like. If I have a charge and I have it move through space, that's called current, right? But current's not enough. Current generates a static magnetic field. I need a changing magnetic field to get this kind of feedback loop in place. So it's not enough to have motion, I need to have acceleration. So when a charge accelerates, it exudes this electromagnetic field, and this is the pattern. It happens to be such that there is no electromagnetic radiation that occurs in the direction of the acceleration, but it's almost all perpendicular, right? It spreads out, splays out like this. The total power that's radiated is given by Lamore's formula here. You see that it's proportional to the square of the acceleration, proportional to the square of the charge, and there's some constants down here. So the faster we accelerate, the more power is radiated. The larger the charge, the more the power is radiated. And because of the way that this is all working, like I said before, the electromagnetic field now is able to actually transfer energy. The total energy content of the field is given by this formula. And you might recognize this formula from when we talked about capacitors. This is why I wanted to mention it there, is that the electromagnetic field, you don't need it to be in a capacitor or an inductor. It can be just by itself, vacuum itself. If you have an electric field and a magnetic field, this is the energy content of that electromagnetic field, no matter what the configuration is. Now, we require a particular configuration for electromagnetic radiation, and in that case, what happens is that the electric field and the magnetic field have to be proportional to one another. And so when that happens, basically the intensity that's associated with that is given by this formula here. Oh, the reason I wanted to mention that is that the intensity is directly proportional to the square of the the electric field. And this might remind you of the energy that's consumed in an oscillating system is proportional to the amplitude squared. And there is an analogy here because fundamentally the mathematics for electromagnetic radiation are the same as any kind of oscillating system, and so we can import a lot of that information. And in fact, that's precisely what Maxwell did in order to calculate this number here.